Hey, what's up everybody? This is your sensei again. Welcome back to the final part of topic 2, which you will see two different types of drawing using OpenGL. Now what will you learn in this topic 2 part 4? You will learn something about the order drawing, followed by the index drawing, and then the difference between the order drawing and index drawing. Now in the previous lecture, we have discussed about the OpenGL pipeline for the modern approach that happens in the GPU, which starts with the vertex shader, followed by the primitive assembly, and then the clipping and rasterization, and then the fragment shader will decide the color for each pixel, and fragment test and blending will decide the final color and display in the frame buffer. Now besides that, we have also seen how to write the code to implement the modern approach of OpenGL that uses the shaders. So far in previous practices, you've been using what's so-called the order drawing. That means that if you want to draw a triangle, you have to list out the vertex information for the 3 vertices that made up that triangle. And you have to define the coordinates of these vertices in counterclockwise order so that the normal is facing you. Now before you can draw anything from the GPU, you have to understand the objects that are available in OpenGL. Now basically, there are 2 different objects that you can use in OpenGL. The first one is what we call regular objects that contain data. The second one is what we call container objects that do not contain any data. Now, in the regular objects, we will be using buffer objects, alright, to store the data from CPU to GPU. But before you can use that buffer objects, you have to bind to a certain target. Now, these targets actually allows the buffers to be used for different purposes. Now, there are several binding points that are available. For example, the GL array buffer, GL element buffer, GL texture buffer, and so on. The one that we have seen so far is the GL array buffer. Once you have bind to this GL array buffer as the target, the buffer object will become vertex buffer object, which behaves as a storage to store any vertex data. So in this code, you have to generate the vertex buffer, and then you have to bind the vertex buffer to a target, which is here we use the GL array buffer. And then you can send the vertex information from CPU memory to GPU memory, and the data will be stored in the VBO located in GPU. Now let's consider the case where you are trying to draw the square shown in this diagram. Now first you have to draw the first triangle, which goes between vertex 0, vertex 1, and then followed by vertex 2. And then you have the second triangle, which goes from vertex 2, vertex 3, and then vertex 0. So you were drawing this in the order manner. Your vertex array would look something like this. You list out the information for 0, 1, and 2. And then you list out another set of vertices that represent the second triangle, which are the vertex 2, 3, and 0. Now, this isn't very efficient when you are dealing with the vertices that are repeated. Consider the case here. The repeated vertices are vertex 2 and vertex 0. Now because it's used in both triangles, that's why you have to list twice. This method is not very efficient, and although it might not seem like a big deal for a small simple case like this, but imagine that if you have a bigger geometry, it means that the more space is wasted, especially as your vertex structure starts containing a lot more data than just the position. So an alternative way to avoid the repeated vertices is to use index drawing. Now the index drawing is a way to define the indices of the vertices, and it's not the real data, in counterclockwise so that it can dereference them to obtain the real data. Now as you can see from this example, the first is the array of vertices, and you just list out the information for each vertices, and then finally you list out the indices that made up each triangle. In other words, index 0 will refer to vertex 0, and index 1 will refer to vertex 1. For index 2 will refer to vertex number 2 in order to form a triangle. Now, in order to work with the element or the index drawing, we have to bind the buffer object to another target we call GL element buffer. And this buffer will be served as the index storage. This buffer can be generated using the GLGenBuffers function with a unique ID corresponding to that buffer. And then you have to bind that buffer object by calling the GLBindBuffers, and the target now is the GL element array buffer. And now this buffer object will become element array buffer object, or in short we say it's a EBO. So this EBO will be able to store and retrieve the index data. Once you have your EBO, then now you can use the GLBufferData function, which copies the previously defined index data into the buffer's memory in GPU. It is specifically targeted to copy user-defined data into the currently bound buffer. Let's look at the same example that we have seen just now. If we use order drawing to draw a square onto the screen, we have to repeat at least two different vertices, vertex 0 and vertex 2. But if we use index drawing, we do not need to repeat any of these vertices. What you should do for the index drawing is to prepare two different sets of arrays. The first array is the vertex information for each point. The second array is the indices that used to form the triangles. As you can see, the first three sets of indices represent the first triangle. The second set of the indices represent the second triangle. Here, index 0 actually refers to vertex 0. Index 1 is referring to vertex 1. Index 2 is referring to vertex 2. For the second set of indices is the vertices that used to draw the second triangle. You see, index 2 is actually referring to vertex number 2. And index 3 is referring to vertex number 3. Index 0 is referring to vertex 0. So 0, 1, and 2 will be able to draw the first triangle, and index number 2, 3, and 0 will be able to draw the second triangle. So you do not need to repeat the vertices. You just need to define the indices. Now let's take a look at the code between the order drawing and the index drawing. Now in order drawing, you have seen this. You bind the vertex buffer to the GL array buffer slot, and then you call GL draw arrays. On the other hand, for the index drawing, it's a little bit different. You still bind the vertex buffer as usual, but you also have to bind the index buffer to the element array buffer slot. Instead of calling GL draw arrays, you have to call GL draw elements. You pass in the number of indices and you pass in the data type you use for each index and the starting point. And then if you use that, it uses the index buffer to look up the triangles drawn from the vertex buffer. So I hope you can differentiate between the order drawing and the index drawing. And I would like to acknowledge the following for the references. And the code for this topic 2, part 4 is: try to keep away from people who try to belittle your ambitions. Small people always do that, but the really great make you feel that you too can become great. Alright, this is actually the quote from Mark Twain. So what we have learned so far in the last part of topic 2 is the meaning of order drawing and index drawing, the differences between these drawing approaches, and the mechanism of sending the vertex and the index data. I hope you enjoyed this video and thanks for watching, and I'll see you next time.